Thanks for joining us and welcome to today's Stabicad Electrical webinar. My name's Joel Gist. I'm the sales manager for the MEP division in the UK. I'm also an account manager to some of our key clients. Typically they're long-time ProDesign users. My colleague Marijn will lead today's demonstration as product manager for Stabicad Electrical. And Radu will support us with the Q&A session at the end. Radu recently joined Trimble from the industry, having been designing MEP systems in plain Revit in his previous role. We'd like to make the session as interactive as possible, so please submit questions throughout. Look for the question mark icon in the panel on the right. We'll answer these after the demo. With a couple of poll questions. Your responses are not public in the sense that they won't identify you to the group, but we'll see the results coming through. So to kick that off, we'd like to ask the first question. Roughly what percentage of your projects are in Revit? 0 to 20, 20 to 50, 50 to 75, or 75 to 100. So you can see some responses coming through now. That's great. So the question again, roughly what percentage of your projects are in Revit? Okay. Thank you. So I have a handful of slides, 4 or 5 minutes to introduce the demonstration for Marijn, then we'll regroup for the Q&A. So once again, please do submit your questions throughout. There's one final question before we get into this, and that's how satisfied are you with your Revit productivity? That's how satisfied are you with your Revit productivity? Not at all, somewhat, satisfied, or very satisfied. Okay. So first, to answer the question, why Stabicad? Always the answer here is that Stabicad makes the engineer more productive. It speeds up the creation of the MEP model. It eliminates the double handling of design information and greatly reduces the chance of making errors. Separate models, as we know, become difficult to manage, especially where design changes are concerned. Another key component of productivity is being able to access high quality, uniform content directly in the software itself. This includes the provision of families and 2D symbols from SIBSI, as well as access to our protective device database, fully supported by the manufacturers themselves. This will be familiar to the ProDesign users amongst us today. With Revit being an American program, it doesn't support the calculation norms our customers typically work with. So Stabicad allows the user to select the norm on a project-by-project basis. Stabicad Electrical's calculation engine is the same as that found in ProDesign for sizing the LV distribution systems. Finally, we follow an open BIM philosophy, which means that our content is fully parametric in plain Revit and accessible to non-Stabicad users. Through the inclusion of Trimble Connect, Stabicad for Revit model can be shared with all project stakeholders via the cloud without the need for individuals to have licenses of Revit themselves. Whilst the Stabicad name might be new to some of our audience today, the software has some 10,000 users, mainly through mainland Europe. but certainly within international companies that also have large presence in the UK. So I'd like to take a moment to acknowledge the journey that's brought us to this point. A lot of people in attendance today have known ProDesign and the old Amtech name for many years, since before we became part of Trimble in 2014. Prior to that, the old Amtech business had been experimenting with the import and export between ProDesign and Revit, and that wasn't without its challenges and limitations. It led us to develop an integrated software by the name of ProDesign 3D with the feedback from our customers. So when Stabicad were acquired by Trimble in January 2018, it was immediately obvious there were great synergies between the two companies. There's a vast amount of Revit experience in the Stabicad team, approximately 200 employees. They've been developing on the Revit platform since the very early days, and before that on AutoCAD. The first collaborative project was to localize the mechanical aspects of Stabicad for the UK, but also the electrical calculations for the European markets for IEC, NEN and VDE norms. And that really brings us up to where we are today. So in December last year, we launched Stabicad Electrical as a subscription bundle. And for those that have experience of Stabicad or ProDesign 3D prior to this point, it's important to point out that all of the functionality from both applications has been amalgamated under the Stabicad name. Traditionally, where Stabicad provided the symbols and the families plus the productivity tools to assist with the creation of the model, time saving and promoting standardization, ProDesign 3D, on the other hand, sought to provide the system sizing calculations, data entry tools, and circuit routing. But this all now exists in the same application. There's one more key component to a Stabicad bundle. Trimble connects our open cloud collaboration platform. Included with each license of Stabicad is a license of Trimble Connect Business Premium. At the core of Trimble Connect is a powerful 3D viewer that can operate through a browser, a tablet or mobile application without the need for a paid license. So Stabicad users can easily upload their models to the cloud where clash detections can take place across multiple models. There's then the possibility for all stakeholders to easily create views with markups and assign to-dos to other members of the project. This can save a lot of time by pinpointing the exact area of the model that requires attention with clear instructions for the owner of the task, both in the Connect platform and via email. Within the wider Trimble Buildings Group, there's an underlying philosophy that our products and services should enable a constructible process through being content enabled, connected, and constructible. This can easily be applied in the context of Stabicad with the provision of MEP content, by connecting all stakeholders via the cloud with Trimble Connect, and with the constructible outputs of Stabicad. So before we hand over to Marianne, we have one last question. It's how would you describe your change management process? We don't have one. There's a process, but there's room for improvement. It works well and changes are efficiently dealt with. How would you describe your change management process? Okay, so that now brings us to the demonstration. where I will hand you over to Moraine.
Thank you, Joel. I've started Stabicad already, which will open the Stabibase application. Now, this application is the central hub of Stabicad, where you can manage your projects and your settings. Now, for example, in this case, I've created a project folder, UK Webinar 12.19, and this folder contains all of the relevant files and folders for this project. We have the electrical and mechanical models, and for the architectural model, I've created a separate subfolder. Now I can double click on the electrical model file and it will be opened in Revit. Once the model has been opened, you can see 3 new ribbons in Revit. And these 3 ribbons contain important Stabicad functions, both generic, relevant for mechanical and electrical, and specific mechanical and electrical functions. Now, in addition to these 3 ribbons, Stabicad also provides you with a palette, and the palette allows you to quickly access many of the functions in the ribbons, but also allows you to place symbols in your project, both for mechanical and electrical. So for mechanical, we have the symbols over here in the blue palettes, and for electrical, the palettes are orange. Now I'm going to hide the mechanical palettes for now, because we're only interested in electrical. And Stabicad by default provides you with a large library of electrical symbols. And for Stabicad UK, we've added additional symbols that have been identified by SIPSI. So we have small power symbols, distributors, outlets, and sockets. We have symbols for lighting, generic lighting, and emergency lighting, lighting switches, and symbols for fire alarm, detectors, indicators, and panels. During today's demonstration, we will start off by showing you 2 Stabicad functions that can save you time while modeling: creating ceiling plans automatically and placing multiple lighting fixtures at the same time according to a grid layout. Then we will show you 2 scenarios where the mechanical model has changed, and this has impacted our electrical model. In the first scenario, we will show you how the circuit management tools can help identify capacity problems in your containments after the load of an air handling unit has increased. And in the second scenario, we will show you how to use our Stabicad function solve crossing to respond to a mechanical duct that now clashes with our electrical containments. We have received an updated model from our mechanical colleagues with some changes, and we've also received additional project specifications from the customer regarding the ceiling plans and the lighting fixtures that will be used. I'm going to start by modeling some of the lighting fixtures on level F01. However, as you can see, I don't have any ceiling plans available yet. Now what I can do is I can use a Stabicad function to easily create the required ceiling plans. So on the StabiTools ribbon, there's the function create plans. And in this dialog, I specify that I want to create plans for level F01 and just a ceiling plan. And I want to create the ceiling plans in the coordination discipline and in the electrical discipline, using the view templates that are part of our Stabicad for Revit template. Now, when I click OK, you can see that a ceiling plan has been created in the coordination discipline. Now, part of the Stabicad for Revit template is also the electrical discipline and a number of views below it that only show a particular category of electrical element in the views. So for example, I have a view that will only show let's say the circuit boards. I have a view that will only show lighting fixtures or my communication elements. Now, for the modeling of the lighting fixtures that I want to do, I'm going to open up the ceiling plan of the lighting subdiscipline in electrical. Now, let's say I would like to model the lighting fixtures in the 3 spaces here at the bottom. Now, of course, I can place each of the lighting fixtures individually, which will take quite some time. However, I can also use a Stabicad function to quickly place multiple lighting fixtures according to a grid layout in each of these spaces. To be able to use that function, I'm first going to place a reference lighting fixture that is then going to be used for each of these spaces. So I'm going to go to the palette and I'm going to choose a rectangular lighting fixture. I want to connect it to the circuit board on this level, and I would like to connect it to circuit number 10. And I'm going to specify a light fixture code. Now, a light fixture code in Stabicad allows you to specify product information for your lighting fixture. So by default, the lighting fixture families in Stabicad are generic families, but by adding product information using the light fixture code, you can make it a specific lighting fixture, including attaching a 3D family that will allow you to override the 3D geometry in Revit of the Stabicad family, and instead it will show you the 3D geometry that you have attached. Now, in this case, I'm going to choose light fixture code A, and I can place this light fixture anywhere I want. I don't necessarily have to place it in the spaces I would like to then place multiple light fixtures. For example, I can now place it just in this corridor. Now, when I've placed it, you will see that the circuit number is shown with a tag, and also the light fixture code is shown with a tag by default. I can then go to the Stabi Tools ribbon again, and I will start the function divider. I want to place the lighting fixtures according to an A to A grid, and let's say I want to place 3 rows and 3 columns of lighting fixtures, and I'm going to draw a rectangular area within which to place the lighting fixtures. I click OK. Now, as you can see in the bottom left corner, I first have to select an element. So I'm going to select the lighting fixture, and I can then drag the rectangular area within which to place the lighting fixtures. I will do that like so. And after I've done that, you can see that I now have a grid of 3 by 3 lighting fixtures in this space with exactly the same properties as the reference lighting fixture. So I'm going to do the same for the other 2 spaces. I'm first going to change the circuit for the second group of lighting fixtures. Go back to the divider function, 3 by 3. I'm going to choose a lighting fixture, the reference lighting fixture, and I'm going to create a rectangular area. And for the third and last space, I'm going to do the same. Start the divider function, 3 by 3. And like this, I now have modeled the lighting fixtures in each of the 3 spaces in a very short time. Now, the create plans and divider functions I have shown are just 2 of the time-saving functions that Stabicad has to offer when modeling your Revit project. Now that we have modeled the lighting fixtures, we can have a look at what our mechanical colleagues have changed and what that means for our part of the model. Now, on the parking level, we've modeled a couple of sockets near individual parking spaces, and we've modeled an isolator representing the load of an air handling unit. Now, each of these circuits has been routed using our circuit management tools. Now, I can show that route by selecting the element and clicking Show Routes. And as you can see, the circuit has been routed using the cable tray containments that are available all the way to the circuit board on this level. Now, the same has been done for the circuits for the sockets over here. Now, we've been informed that the air handling unit has been upsized, and of course that will lead to an increase in load. Now, the load of the air handling unit has been modeled using a Stabicad power code. Now, a Stabicad power code allows you to define an electrical load centrally in Stabicad and then use that power code for multiple elements or family instances in your project, which makes it easy to assign the same type of load or the same value for the electrical load to multiple elements in your model. So for the air handling unit, we've defined the initial situation, an electrical load of 14,000 VA, and we've also defined the upsized electrical load of 40,000 VA. Now, before I assign the increased load or the different power code to the air handling unit or the isolator, I will first check the current cable size. So I will click Edit Final Circuit. And we can see that the current cable size is 1.5 square millimeters. I will then change the power code to the increased electrical load. I will click Apply. And I will recalculate the electrical installation on this level to determine a new cable size for this circuit. There are still no errors, just some notes about automatic cable upsizing for the voltage drop. And when I now edit this final circuit, I can see that the cable size has increased from 1.5 square millimeters to 10 square millimeters. Now, of course, we would also like to share this increased cable size with other people in the project so we can regenerate our reports. Stabicad provides you with a lot of reports showing the calculation results, one of them being the cable analysis report. I will just show the report for the air handling unit circuit. I will zoom in a little bit. Now, as you can see, the cable analysis report shows you, for example, the design current. Let me see, the type of cable that's being used from the regulation, the circuit length, the installation method, some rating factors, calculation results relating to the voltage drop, the protective device that's on the circuit, and calculation results in relation to the earth fault protection. Now, after we have seen that the cable for the circuit has increased in size, we would like to check if this means that we will run into issues in our cable tray containments, because is there enough space in our cable tray containments to route this cable that has increased in size. So what I will do to check that is I will calculate using the circuit management tools. And what we can see is that we will get 3 errors or warnings about containments not having sufficient spare space capacity anymore. So I can click on the Find button, and I will see that the first warning is about the cable tray containment over here. Second warning is for the fitting, and the third warning is for this piece of cable tray containment. Now, what can I do to solve these warnings? In this case, I'm going to increase the size of the cable tray containment. So I'm going to select this piece and that piece of cable tray containment. I'm going to go to the Stabicad Electrical ribbon, and I'm going to choose Change Articles. I can see that the current dimensions are 150 by 60. There's enough space capacity, so I'm going to increase the width to 200. I'm going to click OK, and my cable tray containment has increased in size, including automatically the fitting here in the corner of the bend. Now I can also see a small issue with the saddle over here, connecting the 2 pieces of cable tray containment. What I can do is I can delete the current saddle, and I can use the Solve Node with Options function. Drag the selection area, and I will be presented with a couple of options to solve this node. Now I'm going to choose the first solution, and as you can see, there's now a new saddle placed, connecting properly to the cable tray containment. Okay, so my next step would be to recalculate with the circuit management tools, but I'm going to check first to see if the settings are correct for the cable tray containments. So I will just check the newly placed fitting here, the reducer, and I will have to say that the weight capacity is 65 and the spare capacity can be 25. I will check this piece of cable tray containment. That's okay. I can check this fitting. Okay. 65, 25. That's that. Saddle. And I'm going to check reducer. It's placed here. So once that is done, I can recalculate with the circuit management tools. And I can see that there are no more warnings. So even with the increased cable size for the air handling unit circuit and the defined spare space capacity of 25%, I still have enough room in my cable tray containments. Now the cable tray or the circuit management tools not only warn you about insufficient spare space capacity, but can also warn you about insufficient physical space of the containment. Now, what I shall do to demonstrate that is first connect these 3 sockets to the installation on this level. So I'm going to choose PP, and I'm going to choose circuit number 8 for the first one. I'm going to connect the second circuit to circuit number 9, and the third socket to circuit number PP10. I'm going to use the system browser to, of course, choose the appropriate cable type for the circuits. All of these cable types or Revit wire types are included in our Stabicad for Revit template. I'm going to choose the 4E4 and using our data entry tool, I can also make sure that, let me see, the installation method is what it is supposed to be, 31. I'm going to make sure that the CPC is what we expect it to be. Intro conductor, and I'm going to make sure that the appropriate protective device is selected for the circuits, RCBO. So now, from an electrical point of view, we have set the correct properties for each of these circuits. And what I'm now going to do is route the circuits with our circuit management tools. So I'm going to select all of the circuits and I'm going to choose auto route. So they have been successfully routed, and again I can select them all and I can click show routes, and I will see that all of them have been routed using the cable tray containments all the way to the circuit board. I should then calculate the electrical insulation so that the correct cable size for each of the circuits is determined. And I will calculate with the circuit management tools to see if everything fits. And I now get errors, not warnings, but errors saying the containment has reached or exceeded 100% space capacity. And once again, I can find out which piece of cable tray containment are causing these errors. What I can see is that it's this connecting piece or these connecting pieces that don't have enough physical space. Now I can choose to maybe increase the dimensions of the cable tray, but this time I'm going to choose to add or to increase the number of cable stacks. I'm going to increase it to 2, and I can then calculate again and see what happens, and there are no more errors or warnings. Now, after you've done all of this work, you may want to place annotation tags for one or more pieces of containment, and that tag should display information about the containment itself, but also, for example, about the circuits it's routing. Now, circuit management tools allow you to define shared parameters for your containments that you can then use in your tags. Now, in this case, I've defined 2 shared parameters for our containments, circuits on containment and circuit sizes on containment, and I've linked them to circuit parameters. So with these shared parameters, I can show tags that will show which circuits have been routed on that containment and also the circuit sizes for each of these circuits. So I'm going to go to the palette and I'm going to place the tag tray data. I'm going to click, for example, this piece of containment, and I'm going to place it And as you can see, this tag not only contains information about the containment itself, for example, the dimensions or the elevation, it also shows you the circuits that have been routed on this containment or using this containment and the circuit sizes for each circuit. Now, all of this data is populated by our circuit management tools. And once you recalculate with the circuit management tools, this data will be updated automatically. Now, this is how you can use our electrical calculation in conjunction with the circuit management tools to respond to changes in your model, alerting you to any of the issues that may occur because of these changes. The increased load of the air handling unit is not the only mechanical change in the model. On level F00, the ventilation ducts have been rerouted and they now clash with our cable tray containments. Now, before I have a look at those clashes and try to solve them, I'm first going to route two circuits here in the left part of this level. I'm going to select them and choose to auto route these circuits. Now, after they've been routed, I can show the routes. And what I see is that they're using the cable tray containment closest to the sockets to route to the right, up, and to the circuit board. However, I don't want the power circuits to use this cable tray containment. I only want this cable tray containment to be used by data circuits. Now, what I'm first going to do is I'm going to check the project settings. Because in the project settings, I can set the routing permissions. And when I have a look at the routing permissions, I can see that the service type parameter on the containments is being used to define what type of system is going to be routed in that containment. Now, if the service type parameter has a value of data, I've specified that I only want the data system type to be routed in the containment. And if the service type parameter has a value of power, I only want power circuits or power system types to be routed in that containment. So these settings are what we would expect for a proper routing of power circuits. So I'm then going to have a look at the cable tray containments. And what I see is that the service type parameter does not have a value. And that means that it will be used by any type of system when routing the circuits. So I'm going to select this whole piece of cable tray containment and I'm going to change service type to data. And then I'm going to reroute these circuits. And when that's done, I'm going to show the routes. And now I actually see that they're using the correct cable tray containment to route the power circuits all the way to the left, up, to the right, down, and to the circuit board. So that's what we want. Now, before I solve the clashes, I'm going to write down the circuit lengths. So the circuit length for circuit number 1 is 37.8. And for circuit number 2, the circuit length is 40.8. So now to shift my attention to the clashes. So we have a total of, I think, 4 clashes that I see. One here, one here, one here, and one here. I'm going to solve these 2 clashes. So to solve these clashes, I can use the Stabicad function solve crossing that's available in the Stabicad Electrical ribbon. When I start the function, in the bottom left corner, it says that I need to select a first cutting point. So I'm going to choose one on this side of the clash and then a second cutting point on this side of the clash. And then I can specify how I would like to solve the clash. Well, I would like to solve the clash by going to elevation 2900 in a 45-degree angle, and the center of the cable tray duct should be at 2900 elevation. Then when I click OK, I can see that multiple fittings have been placed, and we can have a look at them in 3D. And we can see that our cable tray is now routed above the mechanical duct. Exactly what we wanted. I can do the same for this clash. Solve crossing, first cutting point, second cutting point, but this time I'm going to go below the mechanical duct, 2600 for the top of the cable tray containment in a 15-degree angle. Okay, and again, when I look in 3D, I can see the fittings that have been placed to go underneath the mechanical duct. Now, these changes to our cable tray containments will have an influence on the circuit lengths. Exactly what influence it has, we can use a scan for changes function of the circuit management tools to pick up on these changed cable tray containments. Now, before I do that, I'm going to make sure that the parameters have the correct values, and I'm going to make sure that the spare capacity for the newly placed fittings is 20% and the max weight capacity is 65. And now I'm going to scan for changes, and I get two messages saying that for the circuits number 1 and 2, components have been altered, and therefore the route has been influenced. And then I have 3 choices. I can do nothing, meaning that next time I scan for changes, I will get this message again. I can choose to clear the route and of course then reroute the circuit, or I can ignore this message, which means that next time I run the scan for changes function, I will not get this message again. I'm going to choose to clear the routes for both circuits. Okay. And I'm going to reroute these circuits. Auto route. Okay, that's great. And I'm going to show the routes just once again to check. So they're still routed using this cable tray containment, and I can see that they're routed also along these newly placed fittings. Now, I then would like to check whether the circuit lengths have changed. Going to select one of the sockets, edit circuit, and I can see that the circuit length now is 38.8, where it was previously 37.8. And for circuit number 2, I can see that the current circuit length is 41.7, and it used to be, or initially was, 40.8 meters. So we can see that the circuit management tools can report on changes in your containment, which will then allow you to reroute the circuits to have a refreshed circuit length. At this point in the project, let's say we're done with all of the cable tray containments, and I'd like to have an overview of all of the pieces of containment that I'm using. What I can do is I can look at all of the schedules that the Stabicad for Revit template gives us by default. So there are many schedules available, and now we're going to focus or show you the E61 cable tray schedules. So in this schedule, you will see for each piece of cable tray containment the dimensions, the width, the height, and the length, and of course the description. So there's an easy overview of all of the pieces of containment that you have in your project, and I have the same type of schedule for your fittings. So here you can see which fittings have been used, how many of each of them, the manufacturer, and a quick description and the dimensions. So this is just another example of how we can use Stabicad and its circuit management tools to respond to changes in the model and be alerted of the impact of these changes on the model. That concludes the demonstration, and I will hand you back to Joel. Joel, take it away.
Thanks, Marijn. That was a really insightful demo. Great to touch on so many aspects of Stabicad Electrical there. So hopefully you can see my slide again here. We plan to share these slides with you after the webinar. So I've included this feature highlight, these feature highlight tiles, so you can speak to your colleagues, remind yourself about some of the functionality that is available in a Stabicad Electrical subscription. So it's also worth mentioning that Stabicad has a whole other side to it in terms of our mechanical feature set. People saying that they can't hear me. Is there, just looking to staff to confirm I am coming through. Okay, so Stabicad has a whole range of mechanical features too. As Marijn showed at the beginning, they're all configurable in the same palette. It operates on the same platform from the same management environment, and that includes the provision of content, productivity tools, and the integrated calculations for ventilation, heating and cooling, tap water, wastewater, and sprinkler. So please look out for Stabicad mechanical webinar content. There's actually an on-demand webinar for our mechanical diagrams functionality that is available through the website. So before we go to the Q&A, I'd just like to summarize the component parts of a Stabicad Electrical subscription bundle. So as we've discussed, Stabicad Electrical represents the amalgamation of our ProDesign 3D and Stabicad applications in one. Trimble Connect Business Premium is part of a Stabicad bundle, as well as access to all the MEP content. But crucially, a Stabicad Electrical bundle also includes the 2D ProDesign applications that a lot of our audience today are using. So the consideration is moving to a subscription to access all of the Revit integrated workflow alongside the 2D products. The 2D products included in the bundle represent our top feature set. So it's 400 boards within ProDesign. It's also multi-region capable. So you can select your calculation norms from BS 7671, from VDE for the German market, NEN for the Dutch market, and there's an IEC, a broader IEC calculation available there too. So yeah, the other thing to point out is that part of the subscription is a high level of support to ensure that you implement the software successfully, and we also offer a range of training to suit the varying needs of our customers. So thank you for your questions. There were a lot of questions, a lot of technical questions. We'll try and answer as many as possible now and follow up afterwards with any that remain outstanding. But perhaps we start with a fairly generic question, which is what kind of content is available in Stabicad? And that will give Marijn some time to prepare some of the other questions. So that's one for Radu, please.
Yeah, thank you, Joel. Maybe it's for me taking some of the generic question that we had and then pass it to Marijn for the specific electrical question. So one of the question was what kind of content is available with Stabicad, and with Stabicad you receive both generic content and manufacturer specific content. These are parametric families that are based on a PLS information. For example, in the demo, we had Marian using the electrical symbols, which were part of the generic content, and then he used some of the manufacturer specific content when he drove the cable tries. These are the parametric families. If you need more detailed manufacturer content, you can always go to our MEP content platform, where you can find a lot of manufacturers. And I think a good point to mention is that families which will be available in MEP content have the right parameters, and you can use them with Stabicad Electrical and Stabicad Mechanical in, for example, calculation and all kinds of functions. Second question that we had, I presume you have used Stabicad Revit template for this demo. What if I have my own Revit template? Can I still use Stabicad? Yes, for this demo we have used our Stabicad Revit template, and this template is part of our offering. So we maintain this template, and then a lot of customers are picking this template, and they are using it with minimal customization. So it's something that is ready for you to start using immediately. For more advanced users who already have their own template, we can cover this option as well. Basically, we'll work together with you, define which is the leading template, and then just import elements from one to another. Once this import is done, then you'll have a new template which you can use for your projects, and it will work with Stabicad Electrical and Stabicad Mechanical. So yeah, you can use your own template if required. Then we had several questions about the create plans. So there was a function in the beginning of the demo which was used to create ceiling plans for multiple levels and disciplines. Can I use this function with my own view templates? The name of that function is create plans, and yes, you can use that function with your own view templates. It's quite easy. Probably we'll work together with you because we need to make a small change. You need to add a code in front of your view template, which is S4R underline, and then the function will recognize that view template as well. So once you do that, when you launch the function, you'll be able to see your view template, and you'll be able to create both ceiling plans and floor plans with your view template. Then we have another question, which again we saw it a couple of times. Can I use my own Revit families with Stabicad Electrical? And yeah, we have this question quite a lot with our customers, and the answer is yes. You can use your family, and it's subject to the workflow and the achievement you need to obtain. So basically, if you want to use a generic family, you can use it with Stabicad modeling functions. You do not need to convert it. Function like the divider tool, which you saw earlier, or family multiplier can be used with non-Stabicad families. However, if you want to be able to use more advanced Stabicad electrical functions like change symbol properties, the one that you saw Marian using in the demo, you need to convert your family to a Stabicad electrical family. But that's quite easy. We have a function for that. You just select your family, click or select a similar Stabicad electrical family, and then we inject the right parameters in your family, which will convert a generic family to a Stabicad electrical family that you can use with all our functions. And I think these are the generic one. Maybe I'll give a chance also to Marian to cover some of the more specific questions. Marian, over to you.
Yes, thank you, Radu. Quite a few questions have come in and are still coming in. So bear with me for a second, because maybe the order of the questions and answers might sound a bit random. So let's just start with some compatibility questions. So one of the questions was, for example, does Stabicad work with BIM 360 hosted models? Yes, Stabicad does work with those hosted models. You can add a link to your BIM 360 environment within Stabibase, and it can then load your models. Compatibility on the side of Revit products. So Stabicad supports Revit 2018, 2019, 2020, and 2021. So we support the same versions that Autodesk supports. Let me see. We had a question about the SIPC symbols that we've shown in the demonstration. Do you have to use those symbols? No, not necessarily. Stabicad provides a large library of symbols or international symbols. So you can either use those symbols or the SIPC symbols that we have provided in Stabicad UK. Let me just scroll down a little bit. Many questions about the circuit management tool, so maybe I can try to answer a couple of those. Let me see. So for example, is there a function to maintain additional spare capacity in containment? For example, 20%. So yes, that is possible. So when you go to the circuit management project settings, there's an option to set the default spare capacity. And this setting will then be used for all of the containment. And in addition to that, you can change the spare capacity on an individual basis if it's needed. Does the number of cable stacks mean that cables are laid on top of each other? So yes, so this is the number of layers of cables you wish to lay on the containment. Joe, I don't know how much time we have left for some additional questions, or do you have something you would like to ask?
So yeah, I mean, there might be another minute or so, and then we'll wrap up.
Okay. So for example, another question for the circuit management tool was, does the software know the diameter of each cable and then apply this to a section of the containment and then automatically calculates the capacity? So yes, that's exactly what we are trying to achieve here. So when you've defined that you want to automatically size all of your cables, you can then run the cable calculation to define the cross-sectional area of the cable. And at that point, the circuit dimension and the weight will be defined. So if on the other hand, you have manually sized the cable, the circuit dimension will be shown immediately. And then the circuit dimension and weight values are pulled from the database if the value is not representative of the data sheets you are using. So we know the diameter of each cable, and we can then apply this to a section of the containment to then automatically calculate the capacity with the circuit management tools.
Okay,
maybe the last one.
Yeah,
or
one more.
Yeah, one
Yeah,
more.
one more.
Are the circuit lengths taken into account when it rises or drops along the containment run? So yes. So we use the containment to route the circuit, and any change of direction will be seen by the circuit management tool. So there are many more questions asked that I could answer, but based on time, Joe, I think this is it.
That's right. So there's one last question actually from us in terms of, would you like more information? So obviously there are questions outstanding. We will have those questions logged so we can start to work through those after the webinar. So we'll, if you've asked a question and we haven't answered it, you can expect a response from us. But yeah, if you could just let us know how we can follow up best with you. We've got the poll displayed on the screen now. Yeah, would you like more information about Stabicad? So yeah, we look forward to continuing the conversation with you, and yeah, really thank you for your time and attention this morning. So once I close the poll, we're just going to display our contact details, so if you're ready to grab those. But yes, just finally to thank you once again, and we'll look forward to speaking to you soon.